Hello and welcome back. Today it's part 2 of the Siglent 3065X-SC, and that is the scanner card. I'm already built kind of a breakout box, and today I want to connect the wiring from the scanner card to the breakout box, and hopefully we can play a little bit with the scanning itself, because in the end that is what it's all about. And we can do little settings from the display, but I think you can also use the software, the SDM. So let's have a look at both. First, the wiring. Well, I'm just looking at the manual, and they say the maximum voltage is the maximum current, and also what type of wire you can use. And they say that the little clips, that they are AWG24. And for me as a European, it doesn't mean too much, to be honest, because I'm used to have square millimeters. But this is 24 AWG, so we're going to use those wires. And well, I look in the Wikipedia, and AWG is American wire gauge. And well, the good thing is they have a translation table. And if I look at 24, then that is 0.2 square millimeters. And then you can run, well, run very hot, 60 degrees, then you can do about 2 amp through it, which is a lot. And just to see, because our main power is like 16, you can do 16 amp, and that's 2.5 millimeter squares. And if I look at that 2.5, it indeed is between 15 and 20. Okay, so that was a quick reference check. Okay, so let's see if I have AWG24 around. Well, I was just thinking, in the end, maybe it can also be a little bit less thick wire, because, well, I'm not going to put high currents or high voltages through it. It's just a breakout box, and I'm just going to play with it a little bit. So I thought, let's use just a patch cable. I have this, I think it's a solid core UTP cable, category 5, and it actually is 4x2 AWG24, so it is even the right cable too. Let me show you. So I thought it would actually be a very bad solution with this wire, but at least the cores are okay, as you can see. If I zoom in a little bit, it actually says AWG24, and it has of course twisted pair, 4 pairs, so then I don't need too many cables. Yeah, capacitance maybe, because it is twisted, it's maybe not the best, but you can see here it can go up to 100 megahertz, because it's a Cat 5e, I think. Yeah, so but for voltage and currents it will be okay. So let's try this. Okay, because I have 16 channels, I need well, this is 4 pairs, so I'm going to need 4 cables, and it needs to be long enough to go all the way to the front. I need to solder it there, and then it needs to be long enough to go into the scanner card, but also I need to be able to remove the scanner card. So okay, so let's do the first cable. It needs to go through this hole. Then you can fix it with this clamp here, and then you need to stick it in there. So I like to have a little bit more length. Okay, I did all 4. I put little rings on it so I know which cable is which. And so I start with the first 2 channels. I start with the brown as the number 1. Let's see if this stripper works. I showed this before, it was the Kaiwitz stripper. No, it just cuts the wire completely. So I need to set it probably to another. Yeah, it doesn't. We'll have another stripper here, but it also doesn't do 24. It does 20. So that's not good. This one does 0.8 and I need 0.2. So I'm going to use the old-fashioned way. And it is just common sense. Don't push too hard. Okay, I'm going to start with the channels 1 to 4 and then channels 7 to up. Because of the sense wire, then we have the high and the low, and then I will do this as the. And now I need something small. So it's all done. I wired everything. Doesn't look bad at all. It actually looks very good. Bit of a closer look. It's all done. I put here a strain release and all the cables done. Because I have two separate boxes here, I also need to think where to put my cables. So I wired my first cable to the channel 1 to 4 because I have 1 to 4. But then here are the sense channels or the channels higher. So I put there 7, 8, 9 and 10. And then on my other cable I put 5 and 6 and the higher channels 5 and 6, 11 and 12. And the last channels are current, so that's my last cable. And then all the wires are exactly in the right boxes. So now I need to solder it. So I will just be putting the card in first, and it needs to slide in. I put some screws in the back later. Then I can put it upside down, and then let's put the cables through. So my cable 1 and 2 go here. Let's see, my cable 1, my cable 2. Okay, perfect. Then my cable 3 and 4, 3 and 4. So I'm gonna push it as far as possible just to make the soldering easier. And later I can just push it back, so I can, if I want, take the scanner card out. So So that is all wired. Hopefully I did it correct. So let's see if I take it out. I could put it maybe on the side. And then I put some tie wraps just to be sure. So then it should be stuck. And then I just close it. Okay. Same for this one. This way around. Stuck at the tie wraps and then gently push. Okay, let's see what I need to do. Switch it on. There is no error message. That would be nice. Okay, how does it work? Well, we need to go to the scanner card, shift the temp. Then we have the scanner. Here we have the scan mode or the step mode. Well, we try the step mode. The time that we have here is between the cycles. So it's now 1 millisecond, but you can also do 1 second. Doesn't matter too much. The number of cycles or auto, that means continuous with this second in between. The channel setup is which one is the lowest channel. That's the channel 1. The highest channel, well, let's say 4. Then we go 1 to 4. Then we have the channel config. Then you have here it's DC volts in the auto range. The speed is slow. That's good. Then we have more digits. And as I explained, the first 12 are voltage. And the last 4 are only for current. And you can't even change the settings for that. It is always fixed to 2 amp. And if you go to the voltage settings, then you can select 2 millivolts. Then it's faster if you don't use auto range. We could use the 2 volts also, but I just keep it to auto mode. So we have now 4 channels back. Highest 4, so we scan over the first 4 channels. So if I say now start, it will start scanning 1, 2, 3, 4. Wait 1 second and go to the next round. Now let's put some voltage on it. I will put one of my voltage source and I will just set it in the channel 1. Let's see what it will do, if it will detect it. Yes, it sees almost 2 volts. So it is now scanning through the first 4 channels. And here you can see it go. And because the time we set to slow to get the multiple digits, it means that the interval between the scanning is always this second. And I didn't find it how to increase it. I think if you do the scan speed maybe faster, then maybe this will also go faster. I can try. So channel setup, channel config, then I can set the speed maybe fast. But I'm afraid if we do that, then we get lower accuracy. So done, done, scan. Yeah, then it goes super fast. And we missing 1 digit. Well, you can hear the relays click a lot. And according to the manual, they can do 100,000 clicks. Okay, that was nice. I set it back to slow. Let's do more channels. Let's do the first 6 channels and just see if I connect everything correctly. Yeah, the cycle interval, I don't mind if that is 0 or 1 second. Start. Yeah, the first channel is 2 volts. Let's go to the second channel. Second channel is okay. Third channel. Yeah. Fourth channel. and fifth is okay. Sixth channel. I like the breakout box, it is really convenient. But the numbering of the channels are a little bit weird because it is 1, 2, 3, 4, 5, 6 and then it is 7, 8, 9, 10, 11, 12. And that is because this is all the ohms and the capacitance and everything that you can measure, and this is the current, and that was specific for these 4 channels. So this is then 9, 10, 11, 12. I also did it like this because if you use resistance you can also do 4 wires, and then you would use channel 1 and channel 7, channel 2 and 8, 3 and 9, 4 and 10, etc. So that's why it's connected like this. But you can also use it for voltage, as we saw in the setup. So if we go to the setup, we stop this channel setup. The highest channel we do now, channel 8. So then 6, 7 and 8. We also gonna scan through this one. Oh, let's scan to 12, why not? All 12 channels for voltage. Start. And then we are now to the 7th. So that should be now, yes, and there it is. Okay, I connected now a real bunch of DC voltage calibrators that I have. My DC voltage sources, all low voltage. And I connected it all to the breakout box. Let's zoom in a bit. So I was able to put the voltage on most of the channels, as you can see, and this is great with the breakout box because now I can really start playing with the scanner card. I have my DMM check plus, I have here the LB02G, I think, the LB02A, the Veneercy, and 2 of the Chinesiums. And I have almost different voltages on a lot of the ports, so I have a closer look on the display. Okay, closer look to the display and start. Let's see what happens if we do this on the computer. The nice thing is the losses are also not that bad because I have my DMM check plus and that one is exactly 5 volts, and here it is also. No, that is not bad at all. Well, let's have a look how that looks on the ECDMM software and make it a little bit bigger. It is alive, so it is probably connected. Let's put it in scan mode. Then we go to the channels. We want to select all the channels. Let me see, I thought the 6th one was not connected. Okay, all the voltage channels we have. Scan data. Let's run the scanner. And here we have our values. Perfect. I only see that if it is exactly 5 volts, it just does a 5. And it is a 6.5 millimeter. I would like to see all the digits. So that's a bit weird in this software. But you do have a min and a max and an average and the amounts of scannings you have. So, and you can export it to a CSV file or anything. I see here there are even trends. There is a trend chart. Well, the values don't change too much. There is not much to see, I would think. Although I can change a little bit my 3 volts. Do we see one going down? Yes, here we have. Can I do it to 1.5? Yes, there it goes down. Okay. I put it back to 3. And we should see that then in the data. The average of that one will be different, and that is this one. Or channel 9. Okay, nice. You can also put a bar chart, but I don't really see how this helps, because I don't really see what it's supposed to do. Oh, yeah. I have no clue what I should do with this. It seems you can also export a scan report, and that is HTML, and then you get this. I only did 2 or 3 scans, but we have here the max, the min, and everything. And also it was possible to use CSV. I don't want to open it in Excel, because then we don't see what the actual format was. But we see here that the values are in the export are not rounded, and then they look a lot better. Here you see my first scan, and you see all the digits. And you see that that 5 volt was actually not 5 volt, but it was 499999965. And we can try to open it in Excel, but sometimes Excel will round it himself by using the free software. Yes. Yes, here is exactly what I mean. It will start rounding, so you don't want that. So I usually use Notepad+, and here you can see exactly the values. So that was it in practice, the scanner card of the Siglent SDM3065X-SC, and it has a scanner card built in, and it is the SC-1016. And we play a little bit with the software, yeah, all the bar charts, and I didn't really see the use yet, but I really watched only a few seconds, just as much as you saw me. And I really think the breakout box is great, because you can connect everything, and I don't need to touch the meter. I can just leave it here, stack other stuff on top, and all the connections are in the front. So that is really cool. Thank you for watching, and I hope to see you next time.